Hello everyone. So today we are again with a new problem which is the largest plus sign. This is a Leetcode September challenge problem and this is a medium problem. So jump into the problem. So we are given an integer n and we have a n cross n binary grid. Binary grid means it contains only zeros and ones. So what actually happens, let's understand because there is a lot of description here for the problem. Okay, so the problem is we have a n cross n matrix, we can say. So in that case my n is equal to the 5 and we have n cross n matrix. So if we give indexing, so it is 0 1 2 3 and 4, and this one is 0 1 2 3 and 4. Now, this grid is a binary grid. It means it can contain 0 or 1. So, the problem is that we have we have an array and the array name is mines. As you can see, the array name is mines and this array contain the coordinates, and that for that coordinate we have 0 value in it. As you can see, if this is our matrix, as you can see there, so for the fourth row and the second column we have a 0 as mine. So what we have to do, we have some mines and we have to find the plus sign, the order of plus sign, the maximum order of plus sign. What does that mean? You can see there is a 0 and we have to find a plus sign. For that you have to understand one thing: we can create the plus sign only if its length and if its, we can say, width are equal, or if we divide it into four parts. So for a middle element, for a middle cell, if we try to find the plus sign, so we can say that for this cell there is a plus sign if the left, the top side of this cell, the left side, right side and the bottom side of this cell should be equal. That's how we can create a cell. Let's suppose if I am considering this one, so there is this and this. This is our horizontal, we can say, cells. So at the left side there are two cells, at the right side there are two cells, at the top there are two cells. But you can see for mines we can't consider it for our plus sign, so we can't take it. So for this we have only one. That's why we don't have to consider it, we don't have to consider it, we don't have to consider it. Every side should be equal. So here you can see from there are two length, there is two length, there is two length and there is two length. That's why our order is 2. So you don't have to confuse that if there is 0 then we have to find a plus sign close to it. No, there is a lot of zeros given to it. In that test case we have only 1 0, but we have a zeros in our grid, and for all that zeros we have to find the maximum order of our plus sign. So in that, if you try at any cell, you find only two order for the cell. Okay, now how we can solve it? So in order to solve it, the problem is very easy. If you see that problem without thinking for the time complexity, how is that easy? See, if we are at that position, you have to calculate what is present to its left, what is present to its top, what is present to its right, and what is present to its bottom. If you can figure out, then you can see, okay, that for this one the plus sign is only 1, because you can see there is no left, there is no top, so this is the only cell. Okay, we can't consider it as the plus sign. So for the first row, if we find it, for all we have only 1 as an order, but as we move down we get 2 as an order, right? Because at this there is 1. For this one, the top is 1, the left is 1, the right is 1, and the bottom is 1. And we want the minimum. Like in that side there are 3, in the top side there are 2, in the right side there are 3, and in the left side there are only 1. So the minimum is 1, so we have to consider 1 from each side so that we can create a plus sign. So if we did like that, it also works. But what we have to do, for each cell for each cell we have to check every row and every column. So if there is n row and if there is n column, then for each cell, or we can say for each cell, which is there are total n cross n cell, we have to calculate its left, bottom, right, and top. So this is a very huge time complexity, and this solution is not working there. So how the problem, we can easily find that we have to do some optimization. How we can do some optimization? See, whenever you try to solve some problem and you have to optimize it, see where we are giving more time. So for each cell, we are finding left, down, top, right again and again. I think we can reduce it. Let's see how. Let's suppose if I am at that position, right? And we have to find the left. I say, okay, I say 4 sides. If I have to calculate the 4 sides for this cell, can I say, understand it, can I say to its left, ask to left, what is the length of your left? So I am at this position and I ask to this cell that what is the length of your left. So it gives me whatever the length it gives me, I just append 1, because this cell is left to it, and whatever it contains the value for its left, we only have to add it. Similarly for top, and similarly for right, and similarly for bottom. So how we can actually do it? See, for this one, when so the another point is, okay, this thing is clear what I will do to optimize it. Now how we can approach it, let's understand that stuff. So you know very well, we we move from there, then this row, then this row, and then we reach at that position. So we reach at that position. Before that, we calculate for all the above cell. So for this cell, we can only get the left and top, because for the below cell, for the right and for the bottom, there is a no computation till now. So from top to down, we have to compute the left part and the right part, because we can do it. This left and this right can be computed for each cell, because when we are at that position, everything above it is computed already. So from top to down, we only find the left and the right and the top. And when we come from bottom to top, we can calculate. See, if we are at this position, let's say, and we compute all that things below it, so we can ask its bottom that tell me that or give me the length of the bottom, and for this right we can ask give me the length of your right, what is present at your right, and we can add 1 to it. Okay, and that is the thing. And the algorithm is very easy. When we are getting left, right, bottom and top, we find the minimum of them. Why minimum? Minimum is for validate plus sign, and the maximum is our answer. It means for each cell we are finding the maximum order of plus sign, and at last we have to return the maximum size, that is what is the largest plus sign the problem is. So see how we can code it. So move step by step. So okay, so just first more other things that I have to discuss. See, in order to solve this problem, this grid is not given to us, we have to create it. This is an imaginary grid, we only have n, and for that n we have to create a grid, right? So for this n we create a grid, and see, for each cell there should be a left, there should be a unique left. For each cell there should be a unique left, right, bottom and top. It means for each cell we have to create four different cells to store the left, right, bottom and top. Now when we are at this position, this first cell, then how we can call the above, because there is nothing at top, then how we can ask that give me your top or give me your left. So for that, what I will do, I will create an extra row at top. I will create an extra row at down, because when we are at that position, we have to call the bottom and right. And similarly, we create an extra column at this side, and we can create an extra column at this side, so that we can call to each side and we can find our answer. Okay, I think this thing is clear. So the first step is to create this grid which is shown there. So first thing is to create a grid. The second thing that we have to do is what, we have to create a four direction grid, which is left, right, top, bottom. So this is four direction grid. The third thing is, for each cell in the grid we have to put 1, but for this mine we have to put 0. So 0 for mine and 1 for all remaining than mine. And after that we have to do a top to down approach and bottom to up approach. And yeah, we can simply do, we can find the minimum for validating plus and maximum as our answer. So I think you can code it from your own. Pause this video here and try to write code from your own, because I actually solve or explain all the aspects, but now you can see the code. So let me just do it. So the code is very easy. Okay. So what we have here, you can see we are creating a grid. Every grid has one value here, right? And then there is an answer which we have to return. Then there is a preprocessor grids. So as I said that we have to create one extra row column, that's why we are making n plus 2, okay, to create an extra row columns. And after that, uh, whatever the wherever the mines we have, for that position we are putting 0, because we don't have to calculate for that, this is the for mines. And now this is the approach, in that we are doing top to down processing, we can say. So in the top to down processing, I will show you. See, when okay, we have to rub it. Okay, so what I'm saying that if let's suppose n is equal to the 5, so and we are making n plus 2, so this is 0 and the last one is 6, right? This is 1 and this is 5, right? This is 0, right? This is 1, right? This is 6, right? And this is 5, right? There is also more grids are there, but I have to tell you what we are doing here. So see, what I am saying that I have to work from 1. Why from 1? From there we have to work, because we use this for left, we use this for top. And similarly, For this thing, I think you have to clear. We have to move from 1 to n plus 1, which means we have to move till 5, because that is the only thing. We have to create this inner as our answer, and we use this auxiliaries row column to find the answer, right? So we did the same, and let's suppose if we are at some position, let's suppose if we are at this cell which is 1 and 1. So for this, the left is that one, so I is 1, j is 1, so left is what? Left is I j minus 1, that's why. And whatever the at the left side, whatever its height, we are adding 1. Similarly for top, if we are at 1, if we are at 1 for top, we have to move above, so this is I minus 1. Similarly, we at that position we are doing bottom to top approach, so we have to work from n is 5. So this thing is used to calculate the bottom and calculate the right. Similarly, if we are at 5 and 5 position, so what is bottom? Bottom is I plus 1. So for bottom there is I plus 1, and for right there is j plus 1, because this is j, we have to calculate for this is j plus 1. And for each cell we have some answer which is the minimum of all. Here we validate our plus sign, and whatever the maximum from the answer so far, and the answer we find there, and at end we have to return it. So let's just submit it and see is that working or not. So yeah, it works very well. Thank you friends, bye bye.